All right, guys, lesson 4, we're going to talk about parallel lines. This is one of the key features of geometry where we're talking about parallel lines. Again, parallel lines are two coplanar lines that never intersect. So they have to be in the same plane and they have to never intersect. So arrows are used to indicate the lines are parallel. So if you notice right here, you have those little arrows. Those indicate, if they don't tell you in the problem, hey, these two lines are parallel, then the picture can tell you they're parallel by using those arrows. All right, and so the notation would be line AB is parallel to CD, and you see the double bars. The double bars, as I told you in a previous lesson, the double bars is shorthand for parallel, so that's how you would write that. All right, a line that intersects two more lines. So if you think about railroads, all right, you have the two rails and then the cross ties. The railroad ties intersect, they connect the two. All right, so it doesn't matter if the two lines are parallel, but if you have a third line that lies across them, that third line is called a transversal. All right, and that by that third line laying over the other two lines, that produces a few types of angles. So on this third figure here, we have angles 1 through 8. All right, you have corresponding angles, alternate interior, alternate exterior, same side interior, same side exterior. So corresponding angles are the same side of the transversal and in the same position. So an example of that would be angle 1 and angle 5. So angle 1 and angle 5, they're in the same position. They're both in the top left corner of those they're both in the top left corner of their angle sets. So angle 1 and angle 5 would be an example of corresponding angles. All right, alternate interior. Well, 4 and 6. They're both inside the line L and M. They're inside the transversal, or they're inside the lines, and they are on opposite sides of the transversal. So alternate interior, so angle 4 and angle 6 are an example of alternate interior. All right, 2 and 8 are examples of alternate exterior. They're on the outsides of those two lines, and they're on the opposite sides of the transversal. So angle 2 and angle 8 are examples of that. All right, same side interior. All right, 4 and 5. 4 and 5. They're on the same side of the transversal, and they are on the inside of those two lines, L and M. So angle 4 and angle 5 are an example of same side interior. Okay, and then 2 and 7 would be an example of same side exterior. They're on the same side of the transversal, and they're on opposite sides, or they're on the outside of the two lines, L and M. Okay, so there's that. Now, what if those two, so if L and M happen to be parallel, then these relationships take on a new meaning. So if the two parallel lines are cut by a transversal, then corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. And if the two lines are parallel, then same side interior angles, same side exterior angles are supplementary, which means they add up to 180. And then don't forget, we've already talked about in the previous lesson that vertical angles are congruent and a linear pair is supplementary. So if we know that angle 6 is 142, what else do we know? Well, we know that angle 1 is vertical to 6, so that's also going to be 142. All right, 3 and 6 are alternate interior. And if these lines are parallel, and we know they are because of these arrows right here, then 6 and 3 are alternate interior, and that would be congruent. So this is also that's also congruent. Also, 1 and 3 are corresponding, and corresponding angles are congruent. 6 and 8 are corresponding, and 3 is also vertical to 8, so this is also 142. So I know that angle 1 is 142. I know that angle 3 is 142. I know that angle 8 is 142. All right. And then 5 and 6 are supplementary. They're a linear pair. So 180 minus 142, that's going to give me 38. Well, 5 and 2 are vertical, so that's also 38. 5 and 7 are corresponding, so that's also 38, and 7 and 4 are vertical, so that's also 38. All right, see how this is like a puzzle? You just kind of put these pieces together. So all these other angles are 38 degrees. 2, 4, 5, and 7 are all 38 degrees. Okay, so that was a taste. Let's look at number 2 and see how things get a little more complicated. All right, so we know from the jump that angle 12 is 121. And because 12 and 7 are vertical, we know that that's also 121. Okay, we also know from the jump that 6 is 75. That also, because 1 and 6 are vertical, we know 1 is 75. And because 6 and 14 are corresponding, we know this is 75. And because 14 and 9 are vertical, we know this inside part is right here, 75. Okay, so angle 1 is 75 degrees. We know that angle 9 is 75 degrees. We know that angle 14 is 75 degrees. Okay, well, let's take a look at what's next. Okay, well, so let's do this. So 75 and 10 add up to 180. So 180 minus 75, that's going to be 105. So this is going to be 105, which means 13 is 105. All right, and that's 105. That's pretty much it. That's all I know at the moment. So 10 and 13 are 105. Okay. Let's see. We have, let's see. We have 121 minus, or 180 minus 121. That's going to give me 59. So 11 is 59. 8 is 59. All right, and because 3 and 8 are corresponding, we know 3 is 59 as well. And because 3 and 4 are corresponding, we know this is 59. All right, that's great. Let's see. It's going to be, so that means 3 is 59. That means 4 is 59. It means 8 is 59. And 11 is 59. We're missing 2. 2 and 5. Okay, so now we need to look at the bigger picture. Angle 1, 2, and 3 all form a straight line. So 1, 2, and 3 add up to 180. Okay, so angle 2 plus 75 plus 59 equals 180. All right, so that tells me, let me use my handy dandy calculator just to be sure. So angle 2 is 46. All right, so that means this is 46. This is 46. All right, there you go. So that's how you would do something like that. And that's how you use all these angles right here. You use all these angles to figure that out. All these right here. All right, now using those same relationships, we're going to set up some problems and work them algebraically. All right, so for number 3, these are corresponding angles, which means they're equal to each other. So I'm just going to set them equal to each other and solve. So 5x minus 2 equals 58. 5x equals 60. X equals 12. Okay. Number 4, these are alternate exterior, and alternate exterior angles are congruent to each other. So 8x minus 77 equals 3x plus 38. All right, so that's the geometry. Now the algebra kicks in. So this is going to be 5x minus 77 equals 38. 5x equals, let's see, it's going to be 115. And so I divide I divide 5, and x equals 23. Okay. Number 5. All right, we got x's and y's. Well, the x's are alternate interior. So I know this angle and this angle are equal to each other. So for the x's, I just set them equal. 8x minus 31 equals 6x plus 3. 2x minus 31 equals 3. 2x equals 34. X equals 17. All right, so I plug in 17. 6 times 17 plus 3 is 105. All right, so if that means this is 105, this is 105, and the y angle is 180 minus 105, which is going to give you 75. So I can set the y 5y plus 35 equals 75. So 5y equals 40, y equals 8. All right, so that's number 5. Last one in this lesson, number 6. Okay, so the x's are alternate exterior. So we have this and this. Those two are equal to each other. So I got 15x minus 26 equals 12, x plus 1. Subtract this is going to be 3x minus 26 equals 1. 3x equals 27. X equals 9. Okay, well, if x equals 9, that means 12 times 9 plus 1. That's going to be 109. Okay, so this is 109. This is 109. Okay, that means this is 109 right here. Let's see. Okay, so this is kind of a preview. The 28, 109, and 4y minus 9, that's a triangle. And the three angles of it inside of a triangle add up to 180. All right, so 4y minus 9 plus 28 plus 109 equals 180. Okay, so 4y plus 128 equals 180. 4y equals 52. Y equals 13. All right, so x equals 9, y equals 13. All right, I hope you enjoyed that. I'll see you in the next lesson.